Okay, so can you see my screen? Okay.
Yes.
Okay. Yeah, so today I will be presenting the paper titled From Foresight to Forethought, VLM-In-the-Loop Policy Steering via Latent Alignment. And this paper was recently published in the Robotic Science and Systems RSS conference in 2025, and also was presented in the iClear World Model Workshop. And yeah, here are some links to the archive paper and also project presentation. And a background of this research is that recently in generative robot policies, like diffusion policy, for example, you can learn a lot of complex multimodal behaviors from just offline demonstrations. But one key bottleneck is that at runtime, these policies usually can exhibit very dangerous degradations, such as either complete task failures or maybe generate behaviors that are misaligned with preferences. And one key question is that how can we improve, given a base imitation learning policy, how can we improve the performance at runtime? And traditionally, the method is that you would like to fine tune the policy with using some additional intervention data or maybe some recovery behavior to be able to handle more diverse situations. But one alternative is by using runtime policy steering, which means that for a policy, you have an external verifier that selects the best actions instead of having a random probability distribution that for that action. And this kind of method of policy steering does not require any additional data, or yeah, that is very expensive to collect. And policy steering, you can think of it as a stochastic model predictive control framework, which means that in policy steering, when you have a policy that can generate behaviors, you have two steps. First is prediction, which means is that given an action plan from the policy, you need to predict the outcome of that action plan. And the second one, you would need a verification, which means you need to verify how well do they actually align with the user intent or the actual instruction. So the key problem here is that how do we how can we do this kind of prediction and verification for runtime policy steering? And in this paper, they presented their approach called Forewarn, which stands for filtering options via representing world model action rollouts via narration. And the key idea here is that they use world models to predict the outcomes of low-level actions, and then they use a external latent aligned VLM as an open world reward function for evaluation, which means that for the prediction part, they use a full model, and then and then to evaluate the actual outcome, they use a VLM to identify if it's a good or a bad action plan. So, and here their framework is divided into two parts, which is the world model part, which includes a pre-training, and then the VLM latent state narration part, which includes some VLM fine-tuning. So initially, to be able to train the world model, so they used the Dreamer V3 world model, and then using some offline data set, which consists of a data set that is from both successful and failed rollouts of the base policy, and then they pre-train this world model to be able to predict outcomes. And after training, the world model is frozen, and then they utilize the observation encoder and also the latent dynamics model that they obtain for the next step, which is the VLM latent state narration. So the next part here is that once you have uh, once you have the world model being able to predict the outcomes, you would need the VLM to be able to reason about these predicted outcomes. And what they propose is that rather than using raw image observations, they want to be able to enable the VLM to reason directly about the predicted latent states that was produced by the world model. So, and they approach this problem as a what they call is a latent text alignment problem, which where like in the previous, for example, original VLM architecture, where you would usually have a vision encoder for the image's observations, they replace that image tokenizer with the world model and the world model encoder and the dynamics model. And then to be able to align the latent and the text representations, they add a linear projection layer. And then because we want the VLM to be able to produce like fine-grained behavior narration for these kinds of so for example, when the robot grasps the cup, you would need more detailed fine-grained behavior, like where does it actually grasp it, like by the handle or maybe by the interior. So to be able to produce this kind of fine-grained behavior narration, they do some fine-tuning for the VLM. And they construct a visual question answering data set to be able to fine-tune this VLM. And then once you have a VLM that is able to reason about these latent states and also produce a very fine-grained behavior narration, you have the VLM to select the best action plan based on this behavior narration by leveraging their open world common sense reasoning. So then to evaluate this two-step two-step prediction and verification framework, they do some experiments where for the base policy, as mentioned, they use the diffusion policy framework, which is a standard imitation learning for robotics. And then for each task, where they have 3 tasks that they evaluate, they train the base policy on 100 demonstrations, which is collected through teleoperation. And for they have 3 tasks, which is the cup task, where the robot has to pick up a cup, and this can be either, for example, by the handle or maybe the interior. And then so you have very multimodal behavior. And then for the bag task, they also have a standard pick task where they have the robot to pick up the bag, but it could be maybe in the center of the bag or maybe in the corner of the bag. And it is also a deformable object, so it increases the difficulty. And then finally, for the final task, they have the fork task, which is required to pick up a fork and then place it into a bowl. And this can also have multimodal behaviors in terms of how you grasp the fork and maybe how you place it inside the bowl. So first, before they actually do the policy steering, they want to know how well does the behavior narration works. So what it means is that given the latent outcomes from the world model, how well does the VLM actually predicts uh, the uh, uh, how well does the VLM actually describes the actual behavior. So as you can see here, for example, when you give the actual images observation, for when the robot tries to grasp the cup, based on several baselines, they see that their method of using forewarn gives a more descriptive behavior description instead of the others. And for example, here they try to ablate and try to compare different things. For example, uh, uh, in VLM Act, for example, instead of using a world model, they just directly fine tune the VLM to generate these descriptions from the observation and the action plan. So without using the world model to predict the outcomes. And then they have VLM image and VLM image oracle, which means that they use a, a model like GPT-4o to generate these behavior narrations zero shot from the visual observations. So so VLM image is from the predicted visual observation, and then VLM image oracle is from the ground truth visual observation. And using some metrics such as ground truth accuracy, which is a binary score that indicates whether the predictions match the actual ground truth narrations, which is decided by the authors or like the human. And then they have the LM score, which is a similarity score from 0 to 1, determined by GPT-4o. And they saw that comparatively, the forewarn method actually performs the best in terms of behavior narration, when compared to an oracle that has access to the ground truth future observations. So it performs the best for this kind of descriptive behavior. So next, after they actually have validated that the behavior nation actually works, the next part is to actually do the policy steering. And they compare here with several different variants. So for example, the first one is the proposed method, which is using the world model prediction plus the VLM verification. And then the next baseline is VLM Act, where it is very similar to the proposed method, but instead of using world model, you have defined the VLM fine-tuned to generate narrations from the observation and action plan. And then you have a VLM DynLat category, which means they still use world model for prediction and VLM for action selection, but they do not use the behavior narration. So they do not use the latent to text alignment. They just have the VLM uh, uh, directly select a plan based on the world model prediction. And then they have a classifier Dyn latent, which is similar to the previous one, but instead of using a VLM for the evaluator, they train a binary classifier to see if it's a good or a bad behavior for the action plan. And some key takeaways here from the result is that when you compare the base policy, which is just standard diffusion policy without any policy steering, compared to the policy steering, they can see that the performance increases drastically. So that means that using some kind of policy steering will have more safe and aligned behaviors by using VLM as the verifier and then of the predicted world model outcomes. And then the second takeaway here, when you compare forewarn with the variants that do not with the variants that are not like using behavior narration. So they see that there's a severe degradation in the performance, especially in novel task scenarios or novel task descriptions. And this means that fine-tuning the VLM to be able to generate behavior narrations is very important to be able to do this kind of policy steering. And they see that, for example, explicitly when you compare forewarn with the variant that does not use the world model prediction, it also performs much worse. So the takeaway is that explicitly having a decoupling between the world model prediction and the VLM verification, it allows for more effective policy steering comparatively. So here's just an example of how an example of a policy steering would go and a visualization. So for example, here, if you have the cup task here, given the observation at step T, for example, you sample actions from the policy, and then you feed it into the world model, and then to have some prediction, so imagination, so predicted latent outcomes. And then you pass this latent to VLM based on that latent to text alignment that was previously proposed. And then forewarn will be able to kind of give descriptions for each of these action plans. And then based on these descriptions, now the robot, they will select the best action plan. So for example, they choose that mode 6 is the best because maybe, for example, that does not spill the drink or that does not touch this inside of the cup. So that is an example of how the method works. So as a summary of this paper is that they essentially propose to formalize policy steering as a stochastic model predictive control problem. And then by using this kind of model predictive control, they leverage a world model for the prediction part and then VLM for the verification part. And they are able to have more effective policy steering and better performance for imitation learning based policy. Yep. So yeah, so that is my presentation, and thank you for listening.
Okay, thank you for your presentation. So, okay, let's move on to the Q&A time. So, is there any questions or comment?
Yes, can I ask some questions?
Yes.
Maybe I missed your explanation. Could you explain why and authors propose to use the world model here? Is it possible to use other models like multimodal large language models here, or the world model is better in this method?
Yeah. So I think specifically here, uh, so as mentioned, like you have the world model and then the also like the VLM. And for the world model, the motivation why they use a world model is because it's much better for future prediction of outcomes. So essentially that's the main. So for example, if you have the action plan from the base policy, like the Vian policy, then they leverage world models that are already shown in previous works that are really good at prediction. So they use world model for that, and then VLM, instead of having the VLM do end-to-end everything, they have the VLM simply as a verifier or a behavior description, which they found was a better method for this kind of evaluation.
Okay, thank you. And the second question is, the experiment is done on the robotics policies, I think.
Yes.
But the method uses both world model and the VLM, which
Mhm.
seems quite large, and I think the robotics need to be processed in real time. What about the process time in this method? Can this
Uh,
be done in real time?
yeah. So yeah, definitely. Actually, one of the results on the paper was about the speed of the policy steering. So overall, when you use this kind of like modular approach compared to end-to-end VLM uh for like yeah, the whole framework, they found that the inference is much faster. So just to give like a number, like when you use like forewarn, like the whole pause part, it takes like 3.7 seconds in total. And then for you when you don't use the world model, you use the VLM for the end-to-end, it takes maybe 22 seconds. But they do also mention that it's still like a bottleneck, as like you have more inference overhead compared to maybe other ways like normal robotics methods. So it's that I think the inference is for future work also. Yeah.
Okay, thank you.
Thank you.
Yeah. Sorry, I had a question.
Yes.
What happens if the world model's predictions are inaccurate? Does Are those results propagated through the VLMs?
Yes. So I think
Yep.
that's a good question. So uh, I think I probably didn't include it in the presentation, but they did have, for example, a comparison where instead of using the prediction from, so I think it was somewhere here. So instead of using a prediction from the, yeah, so instead of relying from the latent dynamics of the world model, they assume ground truth observation. So you can see, for example, here when you use like the oracle, which means they don't use the predictions, it's a higher performance. So definitely using the predicted outcomes will affect the performance compared to the ground truth. But I think comparatively, the world model still performs relatively well, for this specific task, I think. Yeah.
Okay, thanks.
Thank you.
Okay, any other questions? Okay, I have some questions. So first, first I would like to know why you choose this paper. I mean, so could you tell me what motivate you?
Yeah.
Yeah.
So for me, I do, because for me, for example, I've been very interested in kind of verification of like VL, like current
Mhm.
VLAs are very like popular,
Mm,
but
mhm,
there's really little ways to verify their behaviors in terms of safety.
mhm,
So I really
mhm,
like the way they do like verification, and I
mhm,
also really like a more modular approach here where they use dedicated parts. So they use the role model and the VLM. And I think this kind of work was really, I think, very interesting for me. So that's kind of exactly why I chose it instead of other like end-to-end role model approach.
Okay, thank you. So next, according to your presentation, so
Yep.
they say that policy steering can be formulated as probabilistic MPC.
Yes.
So, but I'm not sure whether this is a contribution or novelty of this research. So I want to know. So is this novelty of this research, or had this formulation already been proposed in existing research? So could you please answer?
I think for in terms of novelty, they do kind of claim that that way of maybe having a divide and conquer they mentioned, like having a prediction and then a verification part is their kind of like novelty compared to the other methods. So and I personally don't see actually in robotics too much papers on this kind of method. So I think it's quite novel in that terms, in terms of that. So
Okay, so I understand that. So the novelty of this research, one of the novelty of this research is that the separation they separate and predict. They separate by using world model and VLM to both prediction and evaluation. So okay. So I understand this is a novelty, but I don't understand. So policy steering, they say the policy steering as a stochastic MPC, but so I don't understand. So this is this formulation is novelty or not?
I think they kind of use it as kind of just a inspiration kind of formulation. They don't rigorously mention like that kind of like it's like strictly MPC. So I think in that sense, I also agree that it's not like that part is not a novelty.
Okay. So time's coming, I think. So is there any question? Okay, so that's it. Thank you.
Thank you.